Hi, I'm Andy, and this is my lesson on exiting loops and variable scope in Java. In this lesson, I'll show you how to abruptly exit loops using the keyword break. Then I'll show you how to determine the section of code in which a variable exists, which is known as its scope. Let's get started. We'll illustrate these concepts by writing a program that finds the greatest common factor, or GCF for short, for two numbers, which is the largest number that divides evenly into the two numbers. For example, the GCF for 20 and 30 is 10, because that's the biggest number that divides evenly with both of them. Now there's a really clever and efficient algorithm that finds the GCF using a technique called recursion, but we're going to find it using some more basic programming tools. The first thing we need to do in our program is to ask the user for two numbers. Here's the code that gets those numbers and converts them to integers. Then we need to make a variable to hold the number we're going to try out as our factor. I'll call that variable possible GCF and initialize it to 1 because 1 is basically the default GCF for any two numbers. The first number we should try as our GCF is the largest possible GCF for the two numbers. The largest possible GCF is the smaller of the two numbers. For example, if the numbers are 8 and 112, the largest possible GCF is 8. So we'll assign possible GCF to the smaller of the two numbers using an if-else block of code. Now we need a loop to repeatedly try smaller and smaller possible factors until it finds one that works. Since we don't know how many repetitions that will take, a while loop is more appropriate here than a for loop. Normally I would make this a flag-controlled while loop, but since I want to show you how to break out of loops, we're going to do this one a bit differently. We're just going to put true as our Boolean expression. Now this should give you some pause. Since true is always true, it looks like we're making a loop that will never end, what is called an infinite loop. And normally that is the case. However, since there's a way to break out of loops, even a loop that starts with while true will not necessarily result in an infinite loop. Now let me just say again that I really don't think this is the best way to do this while loop. I think using a Boolean flag will lead to code that's easier to understand. As a programmer, you should always think about structuring your code so you don't have to use while true and loop breaking statements, if possible. We're just doing it this way because one day you might encounter code that works like this and you'll want to know how to analyze it correctly. Okay, so what do we want to do in our while loop? Well, we want to check if possible GCF is a factor of both numbers. And if it is, we're all done. We found our GCF. We'll use the modulo operator to find the remainders when the two numbers are divided by possible GCF. If both remainders are 0, possible GCF is a factor of both numbers. And if it's a factor of both, we're done. We found our GCF, and we can now exit this while loop. To do that, we'll use the keyword break. Break causes the program to immediately exit the current loop, whether it's a while loop like ours or a for loop. So after the program hits the break statement, it immediately jumps down here to the code right after the while loop's closing brace. After the loop is done, we want to print the GCF. Well, at this point, the GCF is stored in possible GCF. So we'll just print its value. Okay, back to our while loop. We need to figure out what to do if possible GCF is not a factor of both of our numbers. In that case, we'll want to try a smaller number next time through the loop. Let's try out our code for two different sets of numbers, 48 and 60, which should give us a GCF of 12, and then 7 and 13, which should give us a GCF of 1. Okay, so that's how you can use break to immediately exit a while loop or a for loop. Now let's shift our focus to variable scope. To show you what that is, let's make a string object here right after we find our GCF. And then down here we'll simply print out message. Let's see what happens when we run our program. So we got a compiler error. The error says cannot find symbol, which is the compiler's way of telling you that I have no idea what this thing is in your code. And right here the compiler tells you the thing it's confused about, in our case, message. Usually I get this error when I accidentally misspell one of my variables, but if you look here we spelled message exactly like we did above when we declared it. So if that's not the problem, what is? Why does the compiler claim that message is an unknown symbol down here when it was clearly created in this if block that occurs earlier? The problem is one of scope. A variable's scope refers to the sections of your program in which that variable is visible, meaning the sections of code in which it exists and can be used. And here's the rule for variable scope. The scope of any variable is the section of code from the point where it's declared to the closing curly brace for the section in which it's declared. That means the scope for our message variable is limited to right here. Anywhere else in the program, message simply doesn't exist. You want to think of variables as having a lifetime. They're born when you declare them, whether or not you actually initialize them. And they die and disappear as soon as the closing brace for their section of code is encountered. Let's try to fix the problem by declaring message right here, at the beginning of the while loop. Although you don't have to, it's always a good idea to initialize variables when they're created. We'll initialize message to an empty string. Now try to predict if either of these two lines of code will cause a compiler error. Okay, let's see. Let's try to understand why we got this error. Since message is declared right here, its scope is this section of code, all the way to the while loop's ending curly brace. Which means this line of code is fine, but this line is not. Message is out of scope here and can't be used. To fix this, let's declare message right before the while loop. Now its scope is this section of code and we should be all set. Let's see. Good, that worked. By the way, you may think that you should just declare all your variables so they have as wide of a scope as possible to avoid these problems. That would work, but declaring variables where they're not actually needed would lead to all sorts of confusion for people reading your code. A good rule of thumb for declaring variables is to declare them so that they have the smallest possible scope needed to do their job. This will lead to much more readable and easy to maintain code. Before we go, let's look briefly at scope for a for loop. Look at this code and try to predict what will happen when we compile it. Notice we got two compiler errors. Both I and j are unknown at this line of code. It's pretty obvious that this is outside of j's scope, but what about I? It turns out that variables declared in this initialization statement have a scope identical to variables declared in the for loop body. That means I has the same scope as j, the body of the for loop. Another way of saying this is that I and j are local variables in this for loop. They exist in the for loop body, but not outside it. To change that, we can declare both I and j outside the for loop like this. Again, make sure you declare your variables to have as narrow a scope as possible. In this case, we had to broaden the scope of I and j to get the program to work correctly, but never do that unless you really have to. And that wraps up this lesson on breaking out of loops and variable scope in Java. I'm Andy. Thanks for watching and coding with me today.